Hi everyone, welcome to ST Skills. This is a weekly system design session of Saturday at 9 a.m. PST. This week we have Dippy presenting on a deep dive on one of the topic, transaction isolation levels. So few months back, like there was a theory session, like if you want to go and refresh later on DDIA, or you can alternatively join on book club to understand the theoretical, but like today she's going to present the deep dive topics. So on every alternate weeks we also have mock interviews, so it's the next week. Like if you want to sign up for any of these sessions, please reach out to me or Asim or DP, and or alternatively you can also sign up in sport.sgskills.com. So with this I'll give forum to DP so that she can get started.
All right, thanks, Naga. Hi, everyone. So this is Deepti Agarwal, and so today, like Asim was mentioning, this was a bit of a last-minute thing that we decided to pick up, and I prepared this topic while going through the book club sessions, um, but yeah, I didn't had a chance to present it there. So, but I'm glad we can use it here. So now, like Naga said, we have talked about this topic twice in a group. Once by Naga, he covered chapter 7, um, and then once during our book club sessions. So many of you here might be probably familiar with what the isolation levels are and how do they behave. Um, is there anyone here who hasn't, maybe attended session or who is not so much familiar with the isolation levels?
Yeah, I am not.
Okay.
Um,
Anyone like, I just want to see, kind of the, in the
yeah,
audience.
I too have missed that session. I was going through the YouTube video, but
Okay.
yeah,
Okay. So yeah, so it's good to have kind of a mix of, I'll accordingly pace it out. So what we decided to do today is rather than going through the definitions or the, concepts, we'll try to have a little bit more hands-on session because I tried these isolation levels using a sample database and I just tried them on a SQL Server. So I thought that can also be a good, can give us good understanding of what they mean. So that's the agenda. And yeah, so just as an introduction, right? What we mean by what isolation levels offer us is that in databases, when you have concurrent transactions, now when I say transaction, I mean that it's a group of read and write statements, right? It's not just a single statement. So basically, when you're having two or more transactions occurring at the same time or interleaved, then isolation level defines uh, when do like the operations within a transaction become visible to other transactions. So in other words, let's quickly look at this table. So what this isolation level would help us is if you have these two transactions running together and transaction T1 updates some data item X, right? When I say write, it can be insert, it can be an update, right? So transaction T1 is trying to update X. The question that isolation level helps to understand is when another transaction T2 tries to read that value, what would be the behavior? Will it be allowed to read that updated value or will it be blocked? That is where isolation levels come in, right? How do you want the concurrent running transactions to behave with all these, concurrent reads and writes? Um, and the other point of isolation levels is why we do this, right? In some cases, in the examples that follow, you would see that in some cases we try to block the reads. In some cases, we allow the reads. Then the question comes that why do we do that? And what are the implications for that? And the answer lies in understanding what are the kind of anomalies that can occur in one scenario versus other, right? So there are a bunch of isolation levels. some allow certain, anomalies, others are more restrictive. So that's where the kind of, you have to identify what's right for your application. And the other thing is you may question here that why do we have so many different isolation levels? Like ideally, you would think that I don't want any anomaly to happen, right? So I would choose that isolation level, which gives me literally zero anomalies or the minimal number of anomalies. And the answer, before me giving the answer, let me just open it up. So would anybody like to comment on this? Like, why don't we have one isolation level, or why don't we follow a certain isolation level which just eliminates or reduces all the anomalies? Why do we have weaker isolation levels?
The performance cost associated with supporting such a isolation level.
Right, exactly. So yeah, thanks. So the thing is, there is a performance implication, right? If you are trying to really, we'll see the kind of anomalies that can happen. And when you try to avoid them, you're actually incurring, either you are including a lot of blocking, in your code, that one transaction has to wait for others, which will in a way impact performance, right? So that's where the trade-off comes in. And like I said, in terms of types of anomalies that can happen, there are, I should have organized this better, but basically like dirty read, non-repeatable read, and phantom reads. These are the read anomalies, and dirty write, and the last two are the write anomalies, right? So we'll, rather than going on definitions for each of them, I would say let's take examples and let's try to see how they work. Now, I don't have examples for every possible case, but at least quite few of them, and we can cover the rest at the end, like concept based. Any questions on anything so far? Okay. So let's start with, so I'll show examples in SQL Server. This is how basically you check what is your current isolation level in your database. So let me switch to the SQL here. So what I'll do is I will start by, I wanted to start by read committed isolation level, but I thought let's even start one step before that. Let's start with read uncommitted, right? So what are the problems that happen there, and how does read committed help with that, right? So that's the flow we will follow. We will try to understand the problems in a certain isolation level, and then we'll try to jump to the next one, which helps to avoid those problems, right? So let's look at read uncommitted. Let me just give example, and then I'll show you an actual, like I'll demo the actual run. So here, what you see is you have this transaction. I have one transaction where I'm trying to update the first name, right? And I have another transaction. Right now, isolation level is uncommitted, and I'm trying to read the data, right? So let's move on to quickly actually testing them out. So you can see SQL Server, right? SSMS window.
No, I'm on this in PPT.
We see the PowerPoint.
Okay. How about now?
Yeah.
Yep.
Okay. So what I did was I have this SQL Server, just public download, and I picked up this database, AdventureWorks, which is again publicly available. And I have the links to it at the end of my slide deck if anyone wants to give it a shot. So what we are doing here is I have this transaction. Let me first even show you that. So you can check what is the isolation level right now. So it's read committed, right? But we want to try read uncommitted, and we'll see how we do that. So in this transaction, let me just kick this off. I did that. And then let's try the second one. So here I'm setting isolation level read uncommitted. So what do you think would be the value I will get? Like, so I updated the first name to Gail for customer ID 345, right? And I have a select query, which includes that 345 ID. So do you think this will give me that, value, or will it?
I think it should give you updated value, uncommitted value, because your level is uncommitted.
Right. So if we see this, we get the, we get the value, and you're not blocked, you just get the value. But now, can anyone point out the problem here?
So other window, we didn't.
Commit is missing.
Sorry. Can you come again?
Commit part.
Right. So yeah, but what about the commit part?
So this transaction is right now is still not. It's kind of live. It's in between.
Right.
We can
Right.
either roll back or commit. And the other side, the transaction level you set to read uncommitted. So that means that we can read uncommitted things.
So that's right. I'm just trying to push a little bit just to make it even more evident. So I think you have the right point that, okay, we are reading uncommitted values, and the problem, like you all suggested, if I roll back, right, this thing, and now if I read it again, right, I mean, I should have first checked the value of first name if it was different. But yeah, so you see how the value went. Yeah, so the value now is different, right? So what is the problem here? So here I roll back, right? I had the original value with different spellings, and this thing read that value, right? The previous screenshot we saw, and then I rolled back and I got the original value. So this seems right? So where is the problem?
There is one thing that I think of: the OS or the database itself has to ensure these transactions are part of the DB, right? So they have to keep certain information. There is an additional property here with the row where you updated. It has to keep track of uncommitted work and committed work, which create trouble with the performance.
Actually, I think what you are alluding to is a little more about that. Yeah, that's true. I think it's also going a little bit into, I don't know if you're hinting towards versioning, like keeping track of different values. But actually there is, that's a different concept so this read uncommitted thing, read committed, all these isolation levels, they come under pessimist concurrency control, right? And the versioning concept that we usually have, I think a flavor of what you are saying is, right. But just to be clear that when we talk about versioning ideas, that each row will have multiple versions and stuff like that, that comes in optimistic concurrency level, which is different. We'll talk about it later. But the problem here is not about performance per se, it's even functional side of things.
Yeah, it's because I read something that's stale, right? That first of all shouldn't have been in the database in the first place. And probably I made a list of actions. Maybe I sent an email to that particular row, which shouldn't have been in the first place, right? Because it was aborted.
Right. So the thing is, yeah, that was a good example. But even pulling back from this, what happened was, before I rolled back, right, this new transaction T2 had this updated value, right? I could have just continued with this transaction and did something more, like I don't know if it was Johnny, but or someone else, but so we could have even took an action over that updated value, right? We could have sent an email to the person, right? And then, or if there is an account balance or something that I updated, I could do further operations on it, continue with it. So let's say I do some more operations, right, on the revised value that was read, right? And while I did that, this thing still hasn't rolled back, right? So I'm doing all good. And then once I do all these operations, and then suddenly this rolls back, right? And then this commits. Do you see the?
Yeah. So yeah,
So
you're
basically
trying
you
to.
are trying to. So basically you're trying to operate on a value which essentially is just disappearing, right? It
We
was.
have a dirty read, right?
Sorry.
A dirty read. That's the problem we are seeing here.
Dirty
Under
read. Yeah,
a
he's
dirty read, because you are doing that select under read
Correct,
uncommitted.
exactly. Yes, dirty. Yeah, correct. But I was just trying to go a little fundamental to explain what's the problem. But yeah, so this is what we use the term called dirty read. So you are trying to read some value which is uncommitted. And the problem there is you can do more operations on it and later realize that was rollback. So you are just, your whole that set of operations is all like kind of on something that no longer exists. Right? Does everybody see the fundamental problem here?
Yep.
Okay. So
DP, just curious to know that, I mean, if there are more than one transaction running and one of the transactions is trying to read the read uncommitted, so
yeah,
the value will be unpredictable or?
well, value, it depends how you say, right? In unpredictable, I'll take another example of that. But yes, that can happen. But also there is even a fundamental problem that the value that you're reading may not be alive after a certain time, right? It just, and you have no trace like the
No, yeah, that's fine. Value will not be, I mean,
yeah,
available at that time. But let's say there are two transactions running and they both actually modified the same value and not committed or roll back. So what the read
right,
uncommitted will get that
right.
value.
Okay. Yeah. So that's a good question, right? So that let's look into it. So the point is you have read uncommitted and you try to update this value, this transaction. Let me know if I'm understanding your question right. And you're saying, what if another transaction also tries to update some value?
No, not with the read commit. So you have two separate transactions running. Go to the second tab. Let's say the same statement to actually you start two transactions. And the first say that change it to that Abigail,
Right.
and the second change it for the same customer, it change it to something else.
Right, which is what I'm doing, right? This is another transaction. This is first transaction, this is another transaction.
And then do the read uncommit.
Right, so this, okay, what do people think? What will happen here? So let's say not even getting into these two windows, conceptually, you have two transactions, both are trying to update value for the same user ID.
Yeah, I think you showed this earlier also. When once you did not roll back, second time you rolled back, the value went back to original. I think there is only one value being maintained. Even if you say that there are two transactions doing Abigail 1, Abigail 2, I believe the most recent will appear.
No, so this is what's happening, right? It won't even, so what you're talking about is the lost update problem, right? One will succeed, other will, override or something like that. But there is a very important concept that comes here, which is that when two transactions are trying to modify the same set of data, right? Then there is, I wanted to bring that point later, but now that we have a question, I'll show it. So let's look at the logs. So you see how both the transaction, first transaction tried to write something, right? And it got an exclusive log, right? It was granted that. Now, two exclusive logs will not work together in the read uncommitted isolation level. So the second transaction, right? And it will happen like right now I have two windows, but even if you hit them at the same time, one of them will be granted the log, other will be blocked because two exclusive logs never work together in read uncommitted. So that's why you see this is blocked. And now if I say this as like rollback, then that will, so this goes on. And now you see here how this is also, no more executing. And if you see the logs, they're gone.
A question I have. So you did rollback only on one of them. The second one was in waiting state and it is lost?
No, it's not lost. It's actually successfully done. So it is no more waiting, right? And then it was able to run. So let's check the value now, right? You see double L here. So what happened is 2 transactions. One had exclusive log granted, which was this one, right? And this is the one I rolled back, right? So this had the log granted and this one was blocked, right? So it was just in a wait mode that as soon as I get the log, I'll go ahead and update it. That's the logic. And then when I went to this one, I rolled it back. So it released the exclusive log and then it was granted to this one and it updated the value.
Yeah, one question for my own understanding. Can you go to the last tab?
Yeah.
So you ran this window first without rollback.
Yeah.
Right? And then you wrote a rollback here. Won't that create a new transaction? You did not roll back an old one. Will this not create a new transaction?
No, so this rollback will be like, there is an open transaction here, right, in the window. So it will.
Are you saying the window is the one that is representing an open transaction here?
No, no. It's not like the window. I can have another begin transaction here. So that's another good point. I can have.
Yes, I got that point. So what I'm trying to convey, when you don't write a rollback, can you just remove? So if you do an execute here, that is gone already. That is dispatched. A transaction has been dispatched, which is uncommitted.
Yes.
It will remain there.
Yes.
Right? Now, when you write a rollback here, isn't this a new transaction that you're initiating, which will be rolled back?
No. Okay, so this is good question. I think the way it works is, I can check the details, but the way it works is somehow database is, somehow database is identifying that it's kind of, bound to this one.
Bound to this particular tab.
Yeah,
I
mean, I don't quite know how it's doing, but
no, I think it works like this. Yeah, so it knows somehow that this transaction status
kind of the handle or something. Yeah.
And you write rollback, it will rolling back that guy.
That guy. Yeah.
And even you can even have written rollback earlier. You are going step by step. You first.
No, but I wanted that interleaving. If I roll back here, right, then this transaction is complete, like it's out. What I wanted to show was how one is having a lock, right?
So somewhere he knows. Even you can give a transaction name. I think so. We can.
Yeah, I mean each database would have its own like those nitty-gritty things, but yeah, just But does this concept make sense? I think overall, when I was studying this isolation level, to me, the biggest thing that I took away from it, and we'll see it in the coming examples, is this locking mechanism. What is compatible, what is not compatible, because otherwise it's very hard to, it almost feels like cramming, right? What isolation level helps with what anomaly. Whereas if we really understand these locking behaviors, that becomes very intuitive, that what will work with in what scenario. But does everybody see the ideas here? So we talked about one idea, which is what is the problem with uncommitted. And we realized dirty read is one. And then we also explained, why that's a problem, because you can work on some uncommitted values and which would be later rolled back. So, and then we also saw how 2 transactions which are trying to modify the same data in read uncommitted mode, one will be blocked because exclusive logs don't work. 2 exclusive logs are mutually exclusive. I mean, they are not compatible basically.
So one question, right? There should be a use case of reading uncommitted as well, right? there is a feature that is there in the database to, it's making you available the uncommitted stuff. There should be a use case.
I think that's yeah. I mean, the fact that it's there, the way I look at this is the default isolation level that SQL Server, for example, provides is read committed, right? Otherwise, they could like why not? Why didn't they go for like uncommitted is on the lowest end of the spectrum, right, in terms of the guarantees. So I guess that's where they start with. And read committed, I'm just bringing up to build the intuition for read committed. Otherwise, it's not really an isolation level per se.
Yeah, I agree. I mean, what you're trying to convey here is somebody is making something a transaction. It means they don't want an intermediate results to be shown up.
Correct,
right?
correct. And maybe like before, like this is like database history is like, research deep, decades long. But maybe at the beginning, this was the feature, right? And then at some point, whenever read committed was designed, right? So this still stayed because it just, this is the basis.
Possibly.
Yeah, but I'm curious now that you asked, like, is there something?
So let me give you, like, it was always committed, but uncommitted was added for us to basically analyze the data in transition. And sometimes you don't need everything to be committed for transactions to proceed. You just need to know, like, if it's there or if it's not, like maybe situations. So in those scenarios, they actually gave multiple options, and even the snapshot is kind of new. Originally, it was only the ones that you see. Committed only was there. Then slowly they added serializable, snapshot, repeatable reads, read uncommitted. These are all added later on. Originally, it was only read committed to follow the ACID principles.
Yeah, that's true. I think, but you kind of also answered the other. I was interpreting the earlier question as why do we even have read uncommitted, right? Like if it's a weak one, if it's give all these problems and it's on the lowest end of the spectrum, then why do we even support this? But I think, like you said, maybe like analyzing data in transition or something like that.
Yeah, not all scenarios you will need. Like in some non-financial scenarios, you're not worried about if it's committed or not. You just want to show some data. It may be updates, like it may be a blog post that you don't. It may update or it may not. It's editable, right? So in that scenario, if someone is reading the blog and you have content, it doesn't matter.
Still feel, I mean, this uncommitted is very confusing. I mean, it's very misleading to the user, right?
Yeah, let's not give examples unless we know them where they're using. So yeah, there may be few scenarios, but I think there may be very edge cases where we use this. Otherwise, yeah.
That's why you should not.
By default, by default, all databases start with read committed. So yeah.
So the one way I can think is maybe just a quick idea, like just like Git, we have uncommitted changes, right? So you can imagine that somebody, a user X, makes uncommitted changes, and then the user Y.
No, I think Git follows even another one. Like there was another one that was talked about in the book, where like if you try to update two different things and one, like succeeds and there is a conflict with another one, so Git reports it, right? Like there is a merge conflict or something.
Optimistic, similar to
Yeah. Right.
Yeah, essentially not the concept of how the how the commits are resolved. My point was like how the use case scenario for this thing. So just what I meant is like if you have all these uncommitted changes by user X and you keep them like that because some other user will then come and review and say, okay, these commits are valid and which are not valid, and then
and on
out of that commit specific record.
I think,
and also just to mention, I guess one thing is, the locking thing incurs overhead. So this read uncommitted is really letting you go, like while there. So it's kind of the performance wise, it's pretty simple, but that can be one thing. But to me, it sounds a little more like Naga is saying, we start with read committed and we this is more.
Always start with read committed. Read uncommitted is for transient data, debugging data, or anything that you want to see when data is in transition.
Yeah, I think in the interest of time, we can go ahead with the DP with other things because they are more important to understand. We can come back to these examples later. Yeah.
Right. So we covered this example where I said, I roll back and I see the different value. But basically the point is in read uncommitted mode, readers are not blocked by writers, right? So when I did something like this, I tried to update a value and I read a value, which is still not committed, it works. But in read committed, that we'll see now, readers are blocked by writers. So think of it this as you're getting an exclusive lock on the write operation and you're getting a shared lock on the read operation, and they are not working, they are not compatible. Let's look at an example for that. So going by the anomalies, we'll see how read committed helps to solve one problem of dirty reads and writes, but it still doesn't solve the other two. And we'll see examples of those. So let me try this. Okay, so here what I'm doing is I have the same example, right? So I'm trying to update the name here, and let's just check that everything is good here. Yeah. So I'm trying to update the name here, and there is another, and this is not committed yet, and another transaction is just trying to read the values. I guess all of you can catch what's going to happen.
So just a small suggestion. It's a instead of that same name, like can you use a different name so it's easy to identify?
Yeah, it's easy to. I really got creative with one L and two L's, and it's like, so let's say I'm trying to update this value here, and let's see the logs now. So you see how I got an exclusive log on this session 51. And now I'm trying to read the values. So anyone wants to guess what would be the output here? Will they succeed? What value it will give, or no value?
Nothing for Alex, I believe.
It will be the earlier committed value only, not like the previous Abigail.
Okay, so Abigail. So one answer is we'll get the previous value, Abigail, and any other answer?
I think they will not get anything because it's an exclusive lock.
Okay, that's second answer. Any other? Okay, so let's see.
You won't get, I guess.
Yeah, so this is getting blocked, right?
Yeah.
Like you said here. So we are.
Oh, okay. So read is also, yeah.
Because you are having read committed. So first one got an exclusive lock, second one got a shared lock, and they are not working together. So it's.
Yeah, it waits, yeah.
Yeah. And then I say. Then this is no more, this finished, right? And we got the older value. Now they're all gone. Makes sense?
The lock was on one row, right?
Lock was on two rows.
Yeah.
Exclusive, and one was shared. Right? So the moment I said rollback, that exclusive lock is gone, right? And as soon as exclusive lock is gone, the shared lock is no more blocked. So that is also gone.
But like, since it can, I mean, like, okay, the query is between 340 and 350. Even if it cannot read one value also, it
Yeah,
is going
like
to, yeah.
345 is like one of the values, right? When it tries to get to that row. And actually you hinted at a very good point about one value versus this sort of range.
Whereas also if you put equal to 345, then it will just wait. But
Yes.
or if you not have not in 345 or something, then it will come. But since it contains 345, it will wait.
Yes, yes. So 345, as soon as it hits that row, right?
Yeah.
That's trying to read. So that's where it just waits.
The range locking takes into effect.
Yeah, but there is more to range locking. I was saying that we'll see ahead. But you're right. I mean, let's not jump too far. But for now, everybody is good with this concept. So we saw what we noticed.
Yeah.
What I want you to keep in mind is the order we went was we had a write transaction, like write update, and then we tried to read that, right? Since it wasn't committed, we couldn't read it, right? So that's the idea we went with. So it avoided dirty read that way, right? And now if we, let's look at, so here I'm showing, that example. And now let's try to, this is another interesting one. So let me bring that up. So let me close. Let's look at another example of read committed and see what that shows us. All right. So here what I'm doing is, all right. So here I'm switching the order a bit. So my first transaction here is reading values between 340 and 350, right? And my second transaction is trying to update one of those values, 345, right? Let me quickly see what value I have here. It's confusing. So what do people think here? So I start with first this transaction.
So you're acquiring an exclusive lock on the table, row number 340, right?
No, this is a shared lock on
No,
this range.
this is just a select query, right?
But it has a begin transaction. I believe this will acquire exclusive lock.
No, this require exclusive lock because it begin transaction is not a problem, right? That doesn't require exclusive lock. Exclusive lock is trying to do an update or insert, right? So this is a read operation. Select star.
In this begin transaction doesn't do anything because it's a select.
No, actually, if somebody
no, it will. No,
it will.
So let me
Acquire.
let me clarify this. And this is the point I want to highlight here. And we'll see the difference it makes in read committed and repeatable read. So when you do in general, right, when you do a select query, that's a read query. And ideally that works in the shared lock mode, right? And whenever we are trying to do an update query, that's working in the exclusive mode. These are general principles, right? Now, what happens in read committed is when you do this select query, it gets a shared lock on each of them, right? And the moment it gets the row back, it releases the lock. It's literally like instantaneous. So when you see the locks here, and I'll give you a example to demonstrate that, another example to demonstrate that. But here, if you see the locks, you don't see any shared lock. That's not because select query did not get any shared lock. That's because that as soon as it acquired the lock and it got the data, it released it. And when I run this query, there is no shared log being held, right? So just if as long as you understand this point, so just stay with me on this and I'll show in the cases where the shared lock is held with the select query. But just you know, let's carry on with this point right now. So we don't have any logs right now. We got shared logs, but they got released immediately. And then I tried to update this.
But in read committed mode,
question there?
Hey, Abhishek, are you trying to say something?
yeah, no, I was saying, but in read committed mode, readers don't block writers, right? So we don't need logs during the read.
I think I'm
Like
just trying to
even the
illustrate
shared
through
lock
example, right? You have the right context, but I'm just trying to illustrate why that happens. So in terms of locking.
Okay. Yeah. Okay.
So yeah. So here I'm trying to. So I have readers, right? Yeah. So I didn't get any logs being held, and now I try to update this, right? And if I check the logs, again, no logs because exclusive lock was requested by it and it was given the exclusive lock because there's no conflict. And then if I try to just run this again, now I see the value Alex, right? So can anybody talk about the problem here? So Abhishek talked about how this is a reader, right? I had a reader, but it didn't block my writer, right?
The problem I see here in this, if somebody want to do an operation here in the begin transaction, I get a row, I increment the row, and then I update a row. It may yield some inconsistent results.
Correct, right? So basically, right now I'm not showing the full picture, but here's the idea, right? I read the data, right? Went well, I got the different value previously. Then in the meantime, another transaction went ahead and updated the value, right? So there's no blocking there. And then even in the simpler case, without even modifying anything, if I do this, I will get different value in the same transaction, right? So this is like non-repeatable read. So read committed helped me avoid the dirty read problem, but it doesn't solve the non-repeatable read problem because readers don't block writers. Does everybody see that idea here?
Yeah. So basically, even if you're in a single transaction, reading multiple times may not give you same results.
Yes, because another transaction updated it and it wasn't blocked. Make sense?
This second read was done while the first transaction was going on, right?
No, first was committed. First was done, right? It's more like see it as I don't have okay, I can draw here.
So then it should have read the updated value because we updated
exactly
committed.
So exactly. So that's what the problem is, right? First time, this is a transaction happening, right? And this is, let's say, the end of transaction. In the transaction, I'm reading this value twice. And during this time, T2 happened. Right? Okay. So here I got the old value, right? Then T2 happened, which changed the value, right? And I let it do it because readers don't block writers. This is my reader, right? This query. And this was my writer, right? So I let it work. And now I tried the query again and I got the revised value.
You got the value you got in the first transaction.
Not in the second. What do you mean?
It's the second select did not yield the same result that first select yielded.
Yeah. So this is one transaction, T1, right? It is having query twice. And between those two select queries, T2 happened, which changed the value.
Yeah, in place of second select, it can be any update or any sequence of transactions. But like the idea is
it has to be it has to be select because we are trying to talk about the read anomaly, right? So non-repeatable read.
Oh, okay. Non-repeatable read problem. Yeah, if you're talking about non-repeatable read.
Change the value. And this one will give, this select will give different value like we just saw here, Alex, compared to what we saw before, which was Abigail.
Okay.
Okay. So we saw like how read committed is working, but now the question is, all right, I don't want this to happen. So what can I do to get a consistent view? Like I don't want this non-repeatable reads to happen. And that's
Repeatable read isolation level, or
yeah. So I just want to see if I had another example. So yeah, like Abhishek was mentioning, the readers do not block writers, and the what was interesting to me is this reasoning, because the duration of the shared lock is it's like momentarily, like when you get the data you release it, you acquire it, you release it, you don't hold it. And if we go to repeatable read now, let's see how that avoids that problem.
Hey, DP, one quick question. A few slides back, right, we saw that the select statement was not returning any results because there was a write that was ongoing. Was that correct?
Yes.
Right. So what was the isolation level under which they were
Yeah, that's
operating?
okay. That's a great point that you brought up. It was still read committed. So this is a question, right? So I have read committed isolation level. And I have two scenarios here. Let me just write it here because it becomes confusing.
Because in that case, it looked like that writer was actually blocking the reads,
Yes,
right?
yes, exactly. So the question is, you have read committed, and the statement I'm making is writers block readers, but readers do not block writers.
Ah, I see. Oh, okay.
Yeah, exactly. That's a good point. Like my understanding was that writers don't block readers.
And readers don't block, right? Because that's what actually DDA says. Right. So even I'm a little bit, because DDA specifically mentions that readers and writers don't block each other. Until snapshot isolation. Even in snapshot isolation, they don't actually block each other.
Snapshot isolation, yeah, it behaves a little different. I think I have it, and it does not block. You're right, because it takes a snapshot. And what you're talking about actually is a read committed snapshot isolation level. Then that's isolation level. But there are so many. It's just
Also, Johnny, I think like this database could have done a different implementation of read committed.
Sure. No, actually, you are right. I mean, different databases have different, but I would still emphasize that what you guys are bringing up, that might be read committed snapshot, which I do have an example of. And in that case, it doesn't block.
I see.
Is there something called read committed snapshot? I mean, like I thought,
yes.
like
Yeah.
because I mean, like in the DDA book, it is just like the snapshot isolation and repeatable read are like almost same. That's what they say. And repeatable read is something that SQL Server and I don't know if DB2, a few of the databases have, but other databases call them as snapshot isolation.
No, snapshot. So here's what, at least what I could see in SQL. There is read committed, right? There is snapshot isolation. There is
okay.
snapshot isolation. So there's so many variations and combinations. But yeah, so there is this one. But does everybody, at least let's go by our current flow.
So there are 5 variations to snapshot isolation.
Sorry?
There are 5 variations to snapshot.
5 variations, yeah. So
put it in chat.
Okay, thanks. So yeah, but everybody is clear on this, a little bit of subtle difference here, like writers blocking readers, not other way around. Because in the
thanks, Vipi.
Yep, thanks.
Okay.
And also based on your application, right? We don't need to set this at transaction level. You can set it at the database level also.
Okay, yeah.
That's something based on your application usage, you can
Sure.
Yeah. Praveen Sataru, like I think I was confused when you said 5 levels of snapshot isolation. So I think you meant transaction isolation level, right?
Transaction.
So when I said snapshot isolation, it is one of that isolation level.
Yeah.
And yeah, I mean, like some databases don't have repeatable read and they just have snapshot isolation. So that's what I was talking about.
DP
Not
showed the database level, so that you can actually change it.
Yeah,
But you may have to restart the service or something.
Right, right. Yeah, since I'm just showing examples, so I'm just taking it every, yeah, correct. Okay, so let's move on to repeatable read. So let's see what this would give us. So I have repeatable read T2. Okay, so I have one select query, right? Same one that I was having in read committed, right? I got the value here. Now, what do you think will happen in this case? Like if I run this, it will succeed, it will block, it will just, update. What will happen?
I think it will succeed.
Yeah, it will update.
Okay, anyone else? So the answer is it will update. And as you can see, it's blocked. And the reason is that's where the difference between read committed and repeatable read comes in. So let's look at the logs. So you see here, this is an interesting point that when we saw read committed and we saw this select query, right? We noticed, I mentioned this point that shared logs are acquired and released immediately, right? They're not held for the duration of transaction. Like this transaction is not committed yet, right? But in read committed mode, I acquired a shared log on row 340. I got the data, I released it. And same way for the other rows. But in repeatable read, it is held for the whole duration of the transaction. So you're having shared logs on all the rows, right? And they are not released. Now, when the next transaction comes in and it's trying to get an exclusive lock on this 345 row, it cannot get it because they are not compatible. And this is the subtle difference between repeatable read and read committed. So now let's try to understand why,
Why was there wait X or why was there waiting for the exclusive lock?
Right, right. So the point is I started the read query first, right? And it was granted shared lock on all of them, right? And I requested an update query and that's put in wait mode, right? Because it cannot get that exclusive lock because S and are not compatible. So it's blocked. Wait is like blocked, right? So whichever thing, let's say in general, I'm throwing an example. If in the read committed mode, when I showed the first example where writers were blocking readers, right? So X was granted and S was in wait mode, right? So whatever comes first will be granted, other one will be blocked. But let me just continue. This was very fascinating to me that what is the implication of this? Let's continue with the previous theory. So here I did this and I am trying to do this, right? This is what we discussed in the last example. So I read a value and it's saying, okay, I have a view of the data and I don't want another view of the data in between, right? Now this T2 is trying to update the view, right, by changing the value. And repeatable read is saying, since I want to ensure a consistent view of the data, I'm not going to let you update the value while I have already read it. Like I'm still in kind of, I'm still not committed or rolled back. So I won't let any value get updated here because if I try to read it again, it will be a different set, right? Does everybody see the catch here? What is
Yeah.
Yeah. Was there a question?
Can you try running this query and also running where customer ID equals to 345?
Sure, sure. So we had this query, right? So what do you want me to? So this is blocked, right?
This is blocked. Just run the select query again, and then where customer ID equals 45.
Okay. So you see, I'm always getting the value Alex because I never let the other query update it.
And what is the logs there for that?
Yeah, so if you just see the logs, so you see, the shared logs on that, whatever is red, and then you have exclusive log on that query that's waiting.
Yeah, this is the typical banking withdraw money and show money, right?
Yeah. So now if I try to, let's say, I'm like, okay, I want this thing to, this value to update or something. So I will, let's say, roll back this transaction. And you suddenly saw how it is no more executing because it is granted that exclusive lock. And now if we try to see the value, let's try to run the value in this thing again. Now you see how it got updated, right? So one important thing is it can be a little confusing for somebody to notice this, that when we talk about repeatable reads, this is in the context of a transaction. So now since my transaction is done, sure, I can go ahead and update the value and I will see a new value. So that's not a problem. The problem is within a single transaction, you should not see two different snapshots of the data, right? Or yeah, basically. Does that make sense, like how this is accomplished?
Yeah, so just to summarize, if my understanding is correct, and a lock will not let anybody update. In the meantime, the lock is acquired. As shared lock will let everybody read, but an exclusive lock is only for that particular thread.
Yeah, so that is a general principle. Exclusive lock is for write and shared lock is for reads. But are you talking more general? Like that, I agree with that on general principles, but that's nothing specific to repeatable. We're trying to summarize that.
No, for repeatable also, what we did, we simply acquired a lock. We will let other readers come in.
Right.
Right. So what you just acquired, basically behind the scene, we are saying it is repeatable, but actually it is doing behind the scene, it is acquiring a shared lock, and it is keeping in that state, so that other readers can read.
Yes, exactly. So shared is compatible, no problem. So readers can read, but it's any update will not succeed because it's holding it shared lock for.
Because the lock is acquired.
Yes.
As simple as that, right?
Yes. No, but the reason I'm emphasizing that is lock acquired thing is very subtle. That is the key difference between read committed. Lock is still acquired and read committed, but it is held for a very small amount of time. It is acquired and released.
Yeah.
Repeatable read.
Yeah. In a regular read pattern, the lock is acquired and released immediately after read is successful.
Yes.
But in this scenario, when you specify here repeatable read, the transaction will keep the shared lock for the time of transaction.
Yeah.
For the consistency of the data that you read.
Right.
So if this was snapshot isolation level, like, are you going to discuss that? Or?
Yeah, I have an example for that also.
So I was just thinking in snapshot isolation level, the writer would be allowed to read, right?
Yes.
Because it can, yeah, okay.
Yeah, it will read the older version and, it will report the older version. So, yeah.
So then repeatable read is stronger than snapshot isolation, right?
Right, sure. Okay. That way you can see it.
Because repeatable read, as the name says, right, it wants to keep the consistency. If you run this query again, you should get the same expected result.
Yeah. Yep, that's the definition.
So I have one question with these two transactions that we just executed. What would happen if we followed the same process that we just did, but before doing a rollback, we add one more commit we add one more update inside a first transaction? I was curious to see that.
Sure. So you're saying, let me just clarify that there's nothing else. Yeah. So you're saying I do this and I try to update something here?
No. So yeah, let's run this first. Yeah, correct. You got it. Yeah.
So this thing, right? So let's run this. So according to me,
Not like this, the other way.
oh.
I mean to say, let's run the select here and run the update in the second session, then come back here and then run the update here.
Oh, okay, okay. So let me just put it here.
Yeah, this is correct. Yeah.
Let's run this one. So this will get a shared lock, right?
Yeah.
Oops, why? Maybe I was updating that. Let me just abort it and run it again, because I think I ran that update and that transaction wasn't complete. So I want to clear this out. Let's start now. So I don't want this. Gave me shared locks. That's good. Now I run this one. So this will be.
Is it blocking?
This is blocking. Right. Now I come back and I do this.
Just run update. Yeah.
So this one is okay. That's yeah. I see what's happening here. So if you see this, there will be only one is granted, one is wait. Okay, can anybody? I mean, this is. I'm glad we are doing this, but anyway.
Yeah.
Since this transaction was already owning the shared lock, so I mean, like it was granted then exclusive as well.
Right. That it's like the isolation levels are trying to track this between transactions, right? So it's like repeatable read is saying this transaction is saying, I know this was the value and I am the one who is trying to update. So that is fine, right? It's like following a sequence. But when another transaction tries to update it, right, that's where isolation level conflicts come up. So if you see the locks here, one of the exclusive lock is granted, which was 51, right? Which is what this one was, right? It was granted here, but the 61 is blocked.
So DP, what will happen if we commit the first update? I mean, yeah, if we commit here, is the second gonna fail?
Okay, so let's see. So if I update this, if I commit this, then I don't have shared lock anymore. And this will also finish.
Both should pass, I believe.
Actually, I should have changed the value to see the impact, right? Now it will be both Alex.
Probably if you change the value out here in that 51, if you change
so this one also worked now. So let me change the value here, right? Alexander. Let's try this. No locks. And let's just run this. And I have the value Alex right now. And this should give me shared locks. All good. And I try to commit this. This is held. And now I try to do it. Let's. And you're saying now according to me, one should be granted, one is waited. And if I commit this one, then the other write will also succeed.
But it will override?
This will override. I think now the value should be Alexander, but let's try. Oops, what is that? Oh. It would dock it. Now I don't have any locks, but let's try to see the value. It's Alexander. Does that make sense? So what we tried to do was we ran this, right? It gave me the value Alex, which was the original value. Then I tried to run this another transaction update and it was blocked, right? Which had the value Alexander. Now I came back to this transaction and I updated the value to Alexa, right? That succeeded and I committed. But the problem is, as soon as I committed this, this was like waiting for, to run. As soon as I committed that, this took, place and it over. This is kind of an example of lost update also, right? That you're trying to update two different transactions are trying to update.
Yes, yeah, it's a lost update.
And then whichever occurred last, right, wins kind of thing, right? So this one happened at the last and that overwrote even this value, Alexa.
Yeah, this transaction is in the queue, right? So it's waiting for the other one to finish.
No, so this is not in the queue. This is in the queue.
Yeah, that one. Yeah, 61 is in the queue. It was waiting for 51 to finish.
Correct.
51 it finishes, it will. Yeah, it's kind of a lost update.
Yeah, it was an interesting point you brought up, like how, S and X works between inter-transactions and intra-transactions, right? Within transaction. Yeah.
But I don't agree with like this is a last update, because if you see from outside of the database, the transaction 1 was an older transaction and transaction 2 was a recent one. So definitely transaction 2, the world decided that this is a new value.
No, but like it wasn't aware of that value, right,
Exactly,
Alexa?
right.
Yeah.
Right. So like it wouldn't have been lost update if it started like, if it read the value here, right? Then it updated and it happened at the end. That makes sense that, okay, I have a, certain value and I'm updating it. But this is happening kind of unaware of this transaction. 61 is not aware that I updated the value to Alexa, right? And it just changed it to Alexander.
Well, so we say lost update because the transaction 60. So if 51 started at time 1, right?
Right.
And 61 started at time 2. So because, and then again imagine there's one more updates at 51 at time 3, right?
Right.
So at time 3 when we did that commit, till time 3 is done, 61 is still waiting, correct?
Sure.
So in that scenario, time 3 should be the final update as per the principles. But but the time 3 is waiting. Time 3 is in 51. It's waiting for it to be committed, and then time 2 61, which is transaction Alexander is waiting. So it will update time 3 1. So in that case, it's a lost update because as per the timing, the Alexa was at time 2.
So this is how, this is how I see it, right? There are two transactions. And if I just see time order, I had Alex here in time, like first one. And then I tried to update it to Alexander, which didn't succeed, which was like in wait mode. And then I tried to update it to Alexa and commit, right? So this thing, as soon as this finished, right, this succeeded, like Alexa. And the way I can check this is I can have another select after my update here, right? So
one point is, even though it's lost update, it's all committed and it's in the logs and everything is tracked. It's not like dirty write or something. Everything can be tracked.
Right, and that way you're saying like it's not something. Sure. Yeah, I mean, it's not like uncommitted read and then overwriting that value. Sure.
Yeah, it's not like that.
From dirty write. It's different from dirty write for sure.
It's not from dirty write. It's all legal and authorized, but it's our logic of how we are.
Perfect.
How you withdraw the money from two transactions come and you have $100, $50. So this Alexa read write can be withdraw money, right?
It can be, but it's also interesting, as we will see in another example, that let's say there might be applications where, like right now we are saying, okay, this succeeded, final value is this, right? And somebody might, if you think about it, somebody updated this value and that person left. So according to that person, the value that went in was Alexa, right? And it was given like commit, all good. But I'm just trying to think thinking of a scenario. I think there is a scenario where in optimistic like snapshot isolation, where it tries to capture a snapshot at the beginning, and then if there is a conflict on version stuff, it doesn't let you update. Like I thought
this, but this repeatable read doesn't do the snapshot method,
yeah,
right?
yeah. No, yeah, sure. It's a different one. I was just trying to think through this discussion about last update.
Yeah, same update will work for balanced scenarios. It should be interesting to check that as a different section.
Yeah. Okay, but does this make sense, this idea?
Yes.
Okay.
Thanks for the interesting.
So this is that. So we looked into how, so we are ahead in the game here. So we looked into this, how repeatable read. So writers are blocked by readers because shared lock is acquired till the end of transaction, right? And then, okay, so phantom reads. Oh, I don't have this insert query example. If we want, we can go through this example live. I don't have this insert query example, but let's go through the example, and if we want, we can always do it there. So we talked about how repeatable read isolation level can help avoid the non-repeatable reads, as obvious as it sounds. But there is another class of anomalies in reads called phantom reads. And rather than giving you a definition of what that is, let me show you by an example what it means. So I have repeatable read isolation level, and I am just trying to read values, right? As you would imagine, it gets shared locks, right, on all the rows. Now what I try to do is, I try to insert a value into my table customer with ID 342. So if you see I'm showing a snapshot of my current, values in the database. I don't have a value 342, right? So I am not trying to get an exclusive lock on an existing value, right? This is a completely new row that I'm getting into. So what repeatable reads, and this is where repeatable reads would create a problem. Before showing you what the problem is, does anybody see what will happen? So I'm saying that third, this box with circle 3 will succeed.
It'll succeed, but we won't read the new value in this transaction. Is that?
No, so you would read, because that's read fail, right? So the problem is when I give this read transaction select query again in the same transaction, it will give me value 342. So you see that the whole essence of our repeatable read isolation level was, I want a consistent view of my.
Okay. Yes. Yeah.
So if there is no new data coming in, repeatable read helps. It doesn't change the data basically, right? But if there's new data coming in, then it will fail there. You insert new rows,
but
now your view has changed.
When we did select and we specified the range from 340 to 350, so it went and got shared log for every row from 340 to, but at that time 342 was not there.
Exactly.
Shared log, right?
Yes. So it never, like, there is no concept of shared lock on 342 because it was never there, right? It only got shared lock on the data that was present in that range. And then I tried to insert a new record, right? There is no conflict there, right? And it went and inserted it. And now if I try the same select query here, and after running this insert here, it will give me this view.
It will give you the 340, okay.
Yeah, so you saw like how my view changed. Initially, I wasn't having 342, and now I'm having 342. So in that way, my repeatable read has failed. It's not repeatable, right? It's giving me two different views.
So this is an example of whenever the long running transactions read queries occur, like we have this phantom read scenarios, right?
No, it's not about long running transaction. It's about inserting new data, right?
Yeah, when another read is happening, is that the
Also, it is something that when you are getting the shared logs, it does not like I was under the impression that it was like when you run this query, it will see what are the rows are selected, and then it will get the shared logs on them
No.
irrespective.
So I think you're talking about index range logs.
uh,
So I think you were
this
talking,
looks like
correct me if
index
I'm,
range log, doesn't
correct
it?
me.
Because yeah, go ahead.
So that is actually another isolation level which talks about what you are saying. Like, correct me if I'm wrong, but I think what you are alluding to is between 340 and 350, I block the whole range. Sort of, I get the shared log on that range. And then if anything happens between it, I'll be blocked.
No, this is what I am getting from this example, that I get log in the range 340 to 350 irrespective of the values that are there or not there. So that's the reason if when 342 came, I still get a lock on it because I already had a lock between 340 to 350.
No, I didn't get a lock on, I didn't get a lock conflict. That's the point, right? When I got in and I inserted 342, if there was a lock conflict, this thing wouldn't have succeeded. But it succeeded because there was no 342 here. So 342 wasn't having any shared lock. So this succeeded. And when I gave this query again, let me, if you want, I can quickly bring up this insert query. But when I run this select query again, after running this insert, I will get this new view where I have this new row.
Okay, I got that. Okay.
Yeah. So in a way, we first pointed out, so the kind of journey we are having here is we started from read uncommitted, which was not good at all because it's giving the problem of dirty reads. Then we went on to read committed, which solves dirty reads, but it doesn't solve the non-repeatable reads and phantom reads. Then we went to repeatable read, and it again lets us cross one of the anomaly, which is non-repeatable reads. But this example shows that it's still not enough because it's not letting us solve the phantom reads problem. Does everybody see the progression here?
Yeah.
Okay. So, and if you want, I don't know, like if you want, I can bring it up, but up to you. If anyone wants to, try this out, want me to try this out, let me know. I was just trying these queries. I didn't get to save them, all of them. So, okay, in that case. So now let's come to what will help us solve this phantom read. So right now, the point where we have solved dirty read, we have solved non-repeatable read, we don't have a solution for phantom reads. And that is where this serializable isolation level is helping us.
So DP, is snapshot isolation before serializable or after?
No, so it's another category. So till now, I'm talking about pessimist isolation levels, and then I'll talk about snapshot.
Okay, got it.
Yeah. So just one thing, since Naga brought that up, that if you think about this whole isolation level concept, there are very high level, there are two categories. One is the category that we have been talking about till now that works heavily on locks, right? They rely on locks to ensure that, what is allowed, what is not allowed. And then in the coming slides, we'll see the isolation levels which which instead work on the versions, like they keep multiple versions and they allow you to incur less overhead because of locks. So, but that's the broad category. So coming to this one, so we saw how we are stuck at phantom reads. So if you think about it, the idea here that this isolation level gives you is that when you try to do this select query, instead of getting a shared lock on these values, it tries to get an index lock, like a range lock, as they say. So it's actually going to block any activity between this range. So now when I try to do the same query here, 342 insertion, it's showing executing, right? It's kind of blocked here. So it's saying that, yeah. So that's the idea, how it's avoiding phantom reads. Does that make sense?
Yes.
Okay. So as a summary, right, not looking, I should have put this table first, because this is very hard to kind of, if you remember the table at the bottom, understand this, then this will be very easy to answer. But what this is like, we talked about this read committed and repeatable read. The difference is in the duration of slogs. And the difference between repeatable read and serializable is the difference between specific row logs and the range logs, right? And you can then see how we just talked about this, right? How each of them is trying to cross one problem at a time. Make sense?
Yes.
Okay. So now let's look at optimistic isolation levels. So,
so one question, so we didn't have any right skew concept here, right? Like in the
So
problems.
this is what, so I don't have example for right skew that I was mentioning in the beginning. It was more mainly about read anomalies I have here.
Okay. Yeah, that's fine.
I didn't get to the point.
Yeah, that's okay. Yeah.
So what we have here is next is optimistic level. And the high level idea is locking, as we saw, that it leads to blocks, right? It leads to blocking of certain transactions. And that's not very welcomed in certain scenarios. You don't want the users to be blocked, and it can also lead to deadlocks. So another solution that people came up with was, all right, I'm not going to block you, but I'm going to create versions of my data, and I'll let you work on, howsoever you want to update data. And then it is the responsibility of the database behind the scenes. It kinds of works with those versions and tries to see, what's allowed and what's not. But that's the high level idea. And let's look at an example. So this is what I was saying. Read committed, if you just see read committed, that's a pessimist isolation level. It works on the basis of logs. But when you add snapshot to it, that's where the versioning comes in. So here I'm setting it to read committed snapshot. So what I did was, this is my initial view of the data, right? 2Ls. And now what I did was I ran, look at how creative I can get. This is like 3Ls now, but whatever. The point is I tried to update the value. And then in the second case, I'm trying to read it. Like I'm putting a lot of data here, but let's pause before getting into third block here. In the read committed isolation level, what would you have expected? So this is trying to update a value. It's not committed yet, right? So if I try to read this, it won't let me read this, right? But in case of, so it will be blocked basically, because this is an exclusive lock and this is a shared lock. But what read committed snapshot will say is, all right, I'm not going to block you, but I am going to give you the value which I had at the beginning of this transaction. So like this transaction took a snapshot of the data, right? And the data was this name with 2Ls. And this transaction also took a snapshot of the data and with 2Ls. So even though this is not committed, but this is saying, all right, the version I know which was committed had this value, right? And this is what I'm going to return. So I'm not going to block you, but I'm going to tell you the value which is I know which is committed, last committed. And now I commit this value. I'm not showing it here, but later on I went in and I committed this, right? And now if I run the select query again, it shows me the new value. So it's kind of, with isolation levels, it's a lot about, you're trying to solve one scenario, but it's like a trade-off you're making. So you can definitely say here, oh, well, this is not really repeatable reads, right? I'm getting two different values. but this is kind of a trade-off, but you're not getting blocked, right? If you're okay to work on, let's say, older value, then this is the way to go. Does everybody see the subtle difference between read committed and read committed snapshot?
You at least get a value here, unlike.
Yeah, exactly. You at least get
known good value you will get.
Yeah, known good value. That was the another thing I wanted to capture here. So we also got a value in read uncommitted, right? But that was not a good value. It could just totally vanish, right? But we know it's committed. Yeah.
So, and what's the difference? How do we do that in DB? Like to get this read committed snapshot isolation?
So it's just like you set this at the database, like I just tried to set this at database level.
The DBCC options, you have to set that.
So yeah, DBCC is more for showing what is this one. But the first one where I altered database and I set this. So this is what I used to set it. Like default is read committed, right? But I wanted to set it to snapshot.
So read committed snapshot is another isolation level.
Yeah.
So to give you one more, I want to add one more thing is you have database level isolation. You have transaction level isolation, like per execution, like 58 session is one transaction, 61, 65. And then you have select level isolation, like when you're doing a selects or update, there are hints there. So even though you have snapshot isolation at that level, when you at your select level, if you say no lock or read committed, that overrides the parent transaction. Just like how this isolation level is read committed snapshot, and we use it like in previous examples, we use transaction level repeatable read, right? So here, the database level transaction gets overwritten. It's like an override class of by repeatable read. And now if you use no lock here, this gets overwritten by for this update, this will get overwritten by the repeatable read. So that's like in
3 different levels of
it's like operator overloading or things.
Yeah. Like more granular, right? What is the granularity at which you're specifying this?
Exactly. So that's one it's a subtle difference, but it definitely based on your application, you can do it. But with all powers comes responsibility.
Yeah. True. Yeah, thank you. So that's that. And this one, okay. I had an example of this, but I don't have an example of specifically. So this one, I think I was finding it hard to how to reproduce or give an example, but what I noticed was, so what I only had, let me go back to this example. So what this read committed snapshot will do is, it will, 1 second. Oh yeah, snapshot thing. So it will, for example, in this second box here, if I had a bunch of, statements, if I have a transaction, right now I only have a single line. So by itself, it forms a transaction. But let's say I had a bunch of statements here and I had one transaction, right? And I am doing certain operations and then select is coming somewhere down, right? And in read committed snapshot, database will capture a snapshot of my data literally at the point where my statement is there, right? So what I'm saying is, let's say before select, I had a couple of updates, right? And then I have a select. So the snapshot value that this transaction will see will be the most recent one capturing the updates that happened before select, right? So there is a difference, right? So if I just illustrate it here. So if I say something like begin transaction, update X to 10, and I say select X. And let's say my original value before starting here was 5, right? So in read committed snapshot isolation, it's a statement level snapshot. So this select will report basically 10, right? But if I'm using just plain snapshot isolation in SQL Server, then this snapshot will be captured at the beginning of transaction. So this thing will still give me 5. Like if I have snapshot, then this should give me 5 because this snapshot was taken at the beginning of transaction in this one, and in read committed, it was taken at the beginning of the statement.
I think the other databases also follow the snapshot isolation, not read committed, right?
Okay.
That's what I understand from the book.
Okay, yeah.
Yeah, because snapshot isolation is the most guaranteed best version known.
Right.
Yes.
Yeah. So so this was that. This was something I just was working on. I haven't yet. I just found it somewhere, but this is a little deep. But I think this was pretty much what I had. I have some references. If you want to try it play it with this database, it's publicly available. Yeah. So that's pretty much what I had. For me, the big takeaways was how these locks are working, shared and exclusive, and how the duration of locks is coming into picture. And then the phantom reads was an interesting idea about range locks and general ones. But yeah, I mean, this is pretty much what I had. If there are any questions or any comments.
Yeah, hey Deep, it was really awesome session. Like, I think for the people of book club, and at least me, I've been reading book, like, and I knew all the theory, but I have never done this practically. And like, it is awesome. Like, it is so much good knowledge for me, and I'm going to watch this video again. Actually, try to implement what you have done. Yeah.
Great. Thank you.
So much for this. Yeah, it's really good.
Yeah, it was really good learning for theoretical people. Yeah.
Yeah,
thank you.
Things that unless you do it in person, you won't understand it. And
it's hard to even retain, right? Like
exactly, yeah.
Yeah.
So many variations that you try, and DP did a great job of presenting and people's questions also. Actually, when people ask questions, right, you actually learn a lot more
Exactly.
by the questions, and it's really. When I did this almost like 15 years back, so the knowledge that I have is very old. But
yeah, and the thing with isolation levels, at least what I've seen is, we are not working on them like, literally a feature, right? So it's kind of easy and it's a little contrived concept. So
Okay, let me stop the recording. Thank you very much, DP, for since we didn't have volunteers, you stepped up and presented a very good topic. Thank you again.
Thanks.
It was a very interesting